Okay, I hope you had a nice break. We are back again with Pedro, who's going to talk about Puppet at the center of everything with a little help from the Forge. Pedro joins us today from Server Density, and we're excited to have him. Round of applause.
Okay, thank you. All right, so I'm going to be talking about how we use Puppet to run server density. So server density is, before I say this, who of you still thinks that monitoring sucks even though we have all sorts of tools, but we still don't get to seem to get monitoring right? Okay, so it's not as bad as I thought. All right. So server density is a monitoring tool that you can buy monitoring from us. So we monitor your servers, and we can also let you know about your websites and the services running on your website, if they are up or down or slow from all sorts of locations around the world. So that's what we do, and we try to make monitoring suck less. By the way, while we are not working on monitoring, we also run some threads on Reddit. This was a thread that we ran a couple of weeks ago asking for sysadmin jokes, and then we got about 300 responses, and we collect them all in a notebook. So if you guys want a free copy, just go to that URL. All right, so how is server density architecture, and what do we run, and where do we run it from? So we standardize on Ubuntu 12.04. So it's not as old software as the satellite software that those guys have up there, but we're pretty much thinking about skipping 14.04 and going straight to 16.04. And we run more than 100 servers of these, all of them with their own Puppet agent, some on public cloud like Amazon, for example, basically to get multiple locations around the world. But the core of our infrastructure is with a data center provider called SoftLayer at Washington, and our secondary data center is in San Jose in California. That's why we have so many servers, and that's why it's important to keep them all in sync. So about 50% of these servers are virtual, the other 50% are dedicated servers that we run entirely ourselves. The only thing that we don't run, and I'm glad we don't run it, is the networking part that we get completely from our hosting providers. But the servers are all run by us. And the workload there is basically nginx, Python behind all sorts of the WSGI servers, and MongoDB is probably the backbone of our infrastructure. We move about 25 terabytes of data per month, and this amount of data comes from every server that our customers have that post back every minute. So every minute we have thousands of postbacks from every single server, from every single customer coming into our infrastructure, so that we can alert you if the load is high, if the server stopped responding, if your service is slow, and stuff like that. How do we use Puppet? What are use cases for Puppet? Well, pretty much everything. So the basic configuration management that I will go into next. Code deploys. So we use Puppet and all the Puppet environment to manage our deploys. And so I run operations at Server Density. I don't even have a track of how many deploys we do per day. I just see them going on the chat window. Once we do a deploy, there's a bot that reports that on the chat window. So every developer can do production deploys, and they do them quite often, several times a day. And this is possible because we've set up a nice environment for them to do that. I will show you that also next. We also use Puppet to ease the 4 a.m. problem that needs a failover of some sort. The guy taking that on-call issue or incident will wake up half sleeping, and he can log on to an easy user interface and do a quick fix and then go back to bed. So it's important that there's not too many buttons to push, otherwise that person may get the wrong button and screw up even more. We also use Puppet for that. And for the system updates, so whenever there's a security update, some new packages, we also use Puppet to roll them out. Okay, now let's start with an in-depth view of those use cases. So the configuration bit. The configuration bit is probably the most usual, I would say. We also use IERA, by the way. We keep all the required configurations that are specific to the environment on IERA. Here's a couple of examples, so that we can have the code without these kind of environment-specific configurations. So that's the configuration. Then the code itself. So we've been using Puppet for over 4 years now, and one hard lesson that we've learned is that always try to reuse as much as possible of existing code. So always go to the forge, don't reinvent the wheel. So for example, for those two configuration sets, the nginx configuration and Apache Storm configuration, we use those modules from the forge. This was actually a hard lesson, and I will show you some more about this later on in the presentation. Because when we started 4 years ago, I'm not even sure if there was a forge. I don't think so. And we wrote tons of code to get going. And now we are paying the price and trying to reduce that code as much as possible. So new stuff, we always look first to see if that problem has been solved before. And for two particular configuration sets that we use, the nginx and the Apache Storm, it has been solved before. It's quite common that the Forge modules don't exactly fit what you need, but usually the authors are very welcome to pull requests, as someone mentioned before. And in fact, we have sent out a few for at least those two modules and more. So once you do that, the code that you have to write is not more than this, so which is a huge improvement from where we were like 4 years ago, where we had to write everything for ourselves. So this is one thing that I'd like to stress out. Don't try not to write more code than what you need to. So try to be as lazy as possible. Right. The next use case that I'd like to share with you is the code deploys. So this involves some in-house tooling, so that once someone commits, waits for the build. By the way, waiting for the build, we use BuildBot. And basically, this is our dashboard for all our systems and the builds that have happened. So you commit, you wait for the green build. By the way, we have no support to deploy red build, so your build has to be passing all the tests and has to be green. Actually, there was one red build before I took this screenshot, but I forced it to rebuild. And it got green, basically because some of our services depend heavily on pulling the latest software from the upstreams, and sometimes those upstreams may be down, so the build needs to be repeated. But this is important also for the developer who is committing and who is about to deploy, to know if their upstream dependency has some problems or not. So we always try to get the latest. then he goes on to check what is deployed on whatever system he wants to deploy. For example, we can see that the green is that everything is at master. The red is unavailable information because those are our standby servers on the secondary data center that usually they are switched off, and we bring them up whenever we need to failover data centers, which happens about once every year or something, but everything is kept standing by there and ready to be started. That's why we see some of the reds, because we couldn't get the latest build from that system. So the developer checks what is deployed. In this case, everything was at master, so there was actually nothing to deploy. But if he was going to deploy one of those systems, it would show a non-master commit there, and it would be okay to deploy. And what does deploy mean? Deploy means going to our deployment selector, or maybe we need to find a better name for it. He goes to the particular system. He can see the servers that that system runs into, and he selects which of the servers he wants to deploy. For example, he may not want to deploy it to every server, so that he can actually confirm if everything will deploy smoothly and will run smoothly, so he can choose one server. And then when he clicks deploy the build, that's where the magic happens, the Puppet magic. So we've written custom package provider like APT, like RPM, so we build our own. And what does that package provider does? It basically implements all that smartness of going to the build server, seeing which version is there, comparing to what is deployed, pulling it, and running it. Running it is that piece over there. So basically, it's like almost like any other package provider. So we want to make sure that particular service is installed on the server. The provider is our own special provider called Honshu over there. There's the dependency, like any other package that we may define. And then what happens after that package is deployed? We have to notify a couple of services because the code changed and they probably need to be restarted. So that's our custom package to make this happen. So the developer pushed those buttons there, click deploy, and some mcollective magic also goes there, so that it can trigger the agent run at the moment that button was pushed. So the workflow in short is push the button, an mcollective call is triggered from there, which will go to those servers that were selected and triggers the execution of the agent on those servers. The execution of the agent will go through that package definition, that custom package definition, and will deploy the code if there is a new version of that package to be deployed. So with this, we deliver to the developer hands the possibility to deploy his code whenever he wants, wherever he wants, without any intervention from the operations people. All right. The next use case is a failover. So as I said, we need a very easy way to change some running parameters of some of the infrastructure without, or trying to avoid as much errors as possible. So the example that I'm going to give you is the nginx on-the-fly update of some of the backends. So it starts with going to the Puppet Enterprise console. By the way, we are heavily users of Puppet Enterprise, mostly because of the console, but actually, to be honest, because it's so much easy to start with. And when we started, we had so much to do that we picked up the Puppet Enterprise. And along with it came the console, which is a big help in this case. And as you can see, there is a couple of definitions here. Basically, some nginx backends. So when something goes wrong, one of the things that we may need to do is switch these backends. So the workflow goes like this: you go into the console, you change those names on the backends. The nginx configuration relies on those names as a variable. It's poorly defined here, but we'll improve that. We'll rely on those names as a variable, and we'll apply that as a backend configuration. So this is the editing UI of Puppet Enterprise. So you basically edit, you change here, and then you save the changes. You go to the mcollective UI of the Puppet Enterprise console. You select the servers where you want to apply those changes, and you force a Puppet run immediately there. And you can see the results. It's important to see the results because for some reason, maintenance and so on, the Puppet agent may be disabled in those particular agents, and that kind of of information you can see here on the result window. So it ends like that. You can also see the log of the execution, what changed. It's on the next tab on the same window, which is helpful. And with that, you can do 4 AM changes without being very afraid of breaking some more than what you had. The next use case that I want to talk to you about is the system updates. Again, mcollective will take a piece in this. So just to be sure, we start with updating the apt cache. You go to the mcollective Puppet Enterprise UI again, and you have one of the actions that you have is to update the apt cache everywhere. So you can see there, I'm about to update the apt cache on 106 nodes because I'm about to start my updates run. And what is my update run? So we start with a small set of servers when we do system updates. By the way, we do this at least every month. There's a specific day in the month for that. We start with what we call the canaries. The canaries is a concept that was used in the mines. So the miners would take a canary, which is a bird, in a cage inside the mine, and because the canaries would die first, then the miner, if there was some gas or some bad environment on the miner could see the canary dying and could get out of the mine before something happened to him. That's why we call these the canaries. They are okay to die first if something bad happens. Basically, it's our staging environment over there, and then a couple of selected nodes. So if these guys die, we know that we have to hold back on the upgrades before understanding better what happened. So those are the canaries, and then this is a little mcollective code, basically iterating through all the canaries and forcing an apt dist upgrade on all of them. We don't have a module on the console to do this, even though we could write it, but it's such a small piece of code that we didn't get around to it yet. You actually can extend mcollective and what shows up there on the console with your own stuff. So that's what we do when doing the system updates. All right. So those are our main use cases for Puppet. Now I'm going to move on to let you know how we reduced our own code base since we started like 4 years ago or something. It involved going through what is available on the Forge. And I'm going to start, well, actually, this is the example that I have. I'm going to show you this example, the MongoDB, which is a very important part of our infrastructure, and it's where we reduce the most of our code base. So we had, for those of you that don't know MongoDB, MongoDB is a NoSQL database that you can configure with replication and sharding, and when you do that, you get all sorts of very verbose setup to manage. So basically, you have arbiters on the elections, you have data nodes, you have router nodes for the sharding, and you have configuration management nodes where Mongo keeps indication where the data is. So I'm going to go through those, all of these types, because this is where our code base actually grew. So Mongo A is the setup of the arbiter. We had 191 lines of code there, plus templates for the configuration files and init scripts. Mongo C is the configuration management node, where we had 179 lines of manifest code, plus templates for the configuration file. The Mongo D is the data-bearing nodes, where you had 257 lines of code on the manifest, plus templates for the configuration files, the init scripts, the PAM, and the limits configuration. And then we had the Mongo S, which is the router for the sharding, where we had 180 lines of manifest code, plus the template for the configuration file and the init scripts. And if we go to the Forge, what do we get? We get not much more than this. Actually, there's a little bit more, but it's not like 1,000 lines of code, which was the sum of the previous. I forgot about the address for the Forge module there, but I will update the presentation when I upload it. So this is what I wanted to show you. You reduce 1,000 lines of code to a couple of tenths of lines of code. So I wanted to show you this example to show how important it is to reuse the code. And currently, I think the Forge is a very interesting tool for that, where we can find other people's shared code that have gone through the same problems. Some of the modules are even supported by Puppet Labs themselves, and in this case, the MongoDB module is actually supported by the vendor, by MongoDB themselves. So which is very good. If you have a maintenance contract, for example, you can actually tell them that you are using their module, and they will help you out with that. So that was reducing the code base with Mongo and the Forge. Now, another use for the Forge that I'm going to show you is how you extend your own product with it, and with Puppet, of course. So I'm going to show you how we extended server density using a module and then publishing it to the Forge so that our customers could use it. So, as I said before, server density collects server data from the servers of our customers using an agent that you deploy to your server. And it's the deployment and management of this agent that I'm going to cover here, and how we used Puppet and the Forge to help our customers deploying this agent and managing it. Okay, what I'm about to describe is the workflow of how to manually use this agent and install it. So basically, you go to the server density UI, you create a device, you copy the agent key, which is the device ID that you see on the UI, and move it to a configuration file. So the agent configuration file is something like that. You have the agent key, and you have your own domain at serverdensity.com. So this is the manual setup. We integrated with Puppet before on what we call server density version 1, where you had a handwritten manifest, nothing integrated with the Forge, and then you just type in the agent key on the node that you wanted, and then it would generate a configuration like that. You do use a configuration like that to generate the agent configuration file. So everything was pretty much manual. Every single of our own customers had to do this, and had to have that code on their side. And it would use a template to generate the exact same configuration as you saw before with the agent key from the template there. What did we do with the version 2 of server density, and what we did to help this improve the agent management? So basically, what we wanted to do is just remove the agent key management altogether. And since the server density version 2 supports groups for devices, the only thing that the customer had to do would be to say which group he wanted the device in, if he was using groups, or it could even skip this step. What happens in the background? You go to the server density UI, create the agent as before, and then it shows on all the agents that you've created show on the UI automatically, and what actually is happening on the Puppet side behind the scenes. A custom fact is returned from the device if it is a cloud instance. This custom fact will report the key itself, and then uses the server density API to automatically create the device on the fly, and then also return that agent key. This is the code for the custom fact, where we basically, if it is a cloud instance which has the agent key automatically created, we retrieve it, and then we use the API and with a custom function to return that agent key back to us, so that the devices are created. You can see here some usage of the API inside that custom function, where we go through the inventory of that particular account to retrieve the device, if it's already available or not. If it's available, we can retrieve the agent key. It goes on to, if the device is not found, it creates a new one automatically for you. And we also add a note to the configuration files that it was automatically created by our module. So once we did this, the next obvious step, once we wrote this code, was publishing it to the Forge. So that's the Forge address for that agent. What this means is that our customers no longer have to write their own Puppet code. They can just go to the Forge and grab our module from there, and we keep it updated. So whenever there is a change on the service, we also change the module, and the customers can update it automatically without having to write a piece of code. So it ties in directly with our release cycle and our changes cycle. So that was it. I tried to speed up things a little bit. I'm not sure if you got to everything, so still have a little time for questions if you'd like to ask them. Thank you. We didn't build a package for our internal software because our development team always likes to try out the latest and greatest tools available, and the software changes so much so fast, and they are not very specialists in packaging. So they are specialists in developing and finding the best tools for the particular service that they are building. So if they would go on and try to package it, it would be another step. So it's not actually a package that we deploy. It's just a tarball, and that custom package provider just untars whatever the build system produced, so that we try to remove every overhead from there as much as possible.
Other questions?
Actually, we didn't. The M collective. So the question was, why didn't we choose to extend the M collective and write an M collective plugin? So we didn't do that because actually the package provider, the package custom provider, comes before we use M collective. So we built the package provider. And then once that was built, we needed a way to immediately trigger the deployment or the upgrade of that package on the server. That's what we use mcollective for. So mcollective ties in with that button where you push deploy to trigger the agent run, which uses the package provider. Oh, okay. Yeah, the reason is we didn't know about that one then.
Any other questions? It's your last chance.
Yes, so I think you're talking about this bit here. Let me. I will repeat the question. This one, that split. Okay. So the question is, why do we use that split over there, and not exported resources? Because at the time we didn't know better. So remember, actually this bit here is over 3 years old, and we still use it. And let me tell you why we did it. So at the time, you see the value here. So there's a host name and a port, then a comma and another host name. So what we needed is to transform this string, because we didn't have any other data type support then, into an array here to supply to members. So if we had an array data type support there, that would be great, but we didn't have that at the time. So you go through all these nice tricks of trying to figure out how to transform strings into useful things, and this is one of them. Yes. Probably is. So what you're talking about here, about there, is the system updates use case here. This one. Yeah. Yeah. So you probably could get away with doing this in a more pretty way, but it does do the trick. So basically, it's a command line MCO call with an exec to just run apt dist upgrade. And the fun bit is that you do get, per canary there, you get an output saying the success or failure of the operation. So you can actually see that on the console. Yeah. Yeah. So it's a quick and dirty solution for running that. So I forgot to say, but after all of this is done, we go on in batches to upgrade the rest of the 100+ nodes in just the same scenario. We group them, and we run the same thing per group.
Any other questions?
So the question is if we played with the mcollective feature of applying or triggering any action to 2% of the infrastructure. No, we haven't, because of the following case. So we need to divide the servers into groups. You saw one of the group, which is the canaries, but then it goes on in more detail. For example, we have a group of half the web servers, then another group of the other half of the web servers, because we don't update them and reboot them altogether, because otherwise the service would be down. And then we do the same for example, the Mongo nodes. We have a group for the secondaries, and then a group for the primaries. So the upgrade process goes group by group, waiting for them to upgrade, to reboot, to recover, and then only then we move to the next. So if we would say, do this to 2% or 10% of the infrastructure, we would lose control of exactly which servers we want to action.
Excellent. Any other questions? Thank you so much.
All right, thank you.